What's inside a black hole? Black holes are mysterious and bizarre objects in the universe that really have no explanation. In fact, we hardly know anything about what lies inside of a black hole. We know and understand what we see on the outside of a black hole, but we have no way of going inside one to take a look at what is really happening. Even if we sent a probe inside a black hole, it would not survive the journey, and there would be no way that the probe could transmit a signal outside once it had been sucked inside. This is because a black hole is the product of mass being squeezed together so densely and so tightly that it creates a gravitational pull that is so strong that not even light can escape its grasp. Supermassive black holes, with masses millions to billions of times that of the Sun, are thought to lurk at the hearts of all galaxies in the universe. You may notice that when you see a photo of a spiral galaxy, such as the Milky Way, in the center of the galaxy is a giant mass of light, which many people would think looks like a massive sun. But this is not light coming from the black hole itself. Remember that light cannot escape the heavy gravitational pull. Instead, the light we see comes from magnetic fields near a spinning black hole that propel electrons outward in a jet along the rotation axis. The electrons produce bright radio waves. Quasars are believed to produce their energy from massive black holes in the center of the galaxies in which the quasars are located. But quasars are so bright, they drown out the light from all the other stars in the same galaxy. You're probably asking, well, what's a quasar? A quasar is the short name for quasi-stellar object and is a very highly energetic object surrounding an actively feeding supermassive black hole. In more basic terms, the supermassive black hole in the middle of a galaxy feeds intermittently. As it feeds, gas swirls around it at incredible speeds and forms an insanely bright hot orbiting disk. And if the black hole is swallowing a large amount of material, this feeding is accomplished by gigantic jets of gas. These are called quasar. They are essentially fueled by the black holes they orbit. Some supermassive black hole giants release an extraordinarily large amount of light when they rip apart stars and devour matter, and are likely the driving force behind these quasars. When material gets too close to a black hole, it forms that bright hot accretion disk around the black hole. That accretion disk heats up to millions of degrees, blasting out an enormous amount of radiation. The magnetic environment around the black hole forms twin jets of material which flow out into space for millions of light years. This becomes what is called an active galactic nucleus, or AGN. The diet of known black holes consists mostly of gas and dust, which fill the otherwise empty space throughout the universe. Black holes can also consume material torn from nearby stars. In fact, the most massive black holes can swallow stars whole. Black holes can also grow by colliding and merging with other black holes. This growth process is what can, and usually does, reveal the presence of a black hole. But supermassive black holes aren't always feeding. If a black hole runs out of food, the jets run out of power and shut down, right up until something gets too close, and the whole system starts up again. The supermassive black hole at the center of our Milky Way galaxy is all out of food or space material to consume. It lies completely dormant for the time being, a sleeping giant, so it doesn't have an active galactic nucleus, and so there is no quasar emitting light. However, we are on a collision course with another galaxy, and in 10 billion years or so, when the Milky Way collides with the Andromeda Galaxy, our supermassive black hole may roar back to life as a quasar as it begins to consume part of this new galaxy. Now, it might sound like black holes are dangerous, and that anything that even remotely comes close to a black hole would get sucked inside and be crushed. And while it's true that if you manage to carefully drop an object into a black hole, you'd never get that object back. But black holes are actually remarkably bad at pulling material close to them. There are a couple of reasons for this. 1. Black holes aren't actually attractive to anything for any reason other than gravity. Much like our solar system is in a stable orbit around the Sun, the vast majority of a galaxy is in a stable orbit around the black hole, with no real reason to go plunging towards the very center of the galaxy. The second reason that black holes are bad at being astronomical vacuum cleaners is that they're really inefficient at getting material close enough to them to cross the event horizon and add to the mass of the black hole. Even small black holes, which exist in great numbers in a galaxy, are much better at tearing a companion star apart than they are at actually growing their own size by consuming the star whole. So despite their reputation, black holes will not actually suck in objects from large distances. A black hole can only capture objects that come very close to it. They're more like Venus flytraps than cosmic vacuum cleaners. For example, Imagine replacing the sun by a black hole of the same mass. Permanent darkness would fall on Earth, but the planets would continue to revolve around the black hole at the same distance and speed as they do now. None of the planets would be sucked into the black hole. Our Earth would be in danger only if it came within some 10 miles of the black hole, much less than the actual distance of the Earth from the Sun, which is a comforting 93 million miles away. So, after knowing all of this, do we have any idea what is inside of a black hole? Current theories predict that all the matter in a black hole is piled up in a single point at the center, but we do not understand how this central singularity works. To properly understand the black hole center requires a fusion of the theory of gravity with the theory that describes the behavior of matter on the smallest scales, called quantum mechanics. This unifying theory has already been given a name, quantum gravity, but how it works is still unknown. This is one of the most important unsolved problems in physics. Studies of black holes may one day provide the key to unlock this mystery. Einstein's theory of general relativity allows unusual characteristics for black holes. For example, the central singularity might form a bridge to another universe. This is similar to a so-called wormhole, which is a mysterious solution of Einstein's equations that has no event horizon. Bridges and wormholes might allow travel to other universes or even time travel, but without observational and experimental data, this is mostly speculation. We do not know whether bridges or wormholes exist in the universe, or could even have formed in principle. By contrast, black holes have been observed to exist, and we understand how they form. What is actually inside of a black hole is still a mystery. So does a black hole live forever? If there is nothing for a black hole to consume, then no. In fact, a very surprising thing happens. You might have heard of Stephen Hawking. He is a theoretical physicist and cosmologist and is at the forefront on the study of black holes. He came up with a theoretical prediction that black holes emit radiation. This, of course, is now known as Hawking radiation. Hawking radiation reduces the mass and energy of black holes and is therefore also known as black hole evaporation. Because of this, black holes that do not gain mass through other means are expected to shrink and ultimately vanish. What it means is that if the black hole has nothing to eat, it eventually evaporates. The energy and mass that the black hole pulled inside of itself evaporates back out into space in the form of radiation. It is almost as if a black hole is a universe recycling machine. Stephen Hawking proved this in 1974 by using the laws of quantum mechanics to study the region close to a black hole horizon. The quantum theory describes the behavior of matter on the smallest scales. It predicts that tiny particles and light are continuously created and destroyed on subatomic scales. Some of the light thus created actually has a very small chance of escaping before it is destroyed. To an outsider, it is as though the event horizon glows. The energy carried away by the glow decreases the black hole's mass until it is completely gone. This surprising new insight showed that there is still much to learn about black holes. However, Hawking's glow is completely irrelevant for any of the black holes known to exist in the universe. For them, the temperature of the glow is almost zero, and the energy loss is negligible. The time needed for the black holes to lose much of their mass is unimaginably long. However, if much smaller black holes ever existed in the universe, then Hawking's findings would have been catastrophic. A black hole as massive as a cruise ship would disappear in a bright flash in less than a second. As you can see, black holes are incredible and mysterious things. Perhaps one day we will know exactly what lies inside of a black hole. Maybe we will find out that they are gates to another dimension, such as wormholes. Or maybe we will never know, and just come to accept their existence as they are.